Hello, folks. Thanks for being flexible, right? Um, so what I'm going to do in this little set of slides is I'm going to finish up our section on study design, just kind of finishing up talking about odds ratio and relative risk. And then there will be a second set of slides for today's lecture that's moving on to how to calculate statistics. So make sure that you watch both sections. There'll be two separate files. So I don't know. If you have any questions or concerns, please let me know, and I'll see what I can do. Okay, I want to remind you that an odds ratio is the odds of people with the disease being exposed uh, in comparison to the odds of people with the disease not being exposed. So just to be really explicit about where this math equation right here comes from. What it is because we've got an odds ratio, so we have the odds of people with the disease who are being exposed. So we have then the odds of people uh, with the disease being exposed. So we have 215, sorry, I'm doing this with my finger, over 785. So that is right here, the odds of the people with joint pain who run more than 25 miles per week compared to those who have joint pain but are not exposed, do not run over 25 miles per week. And then we divide that because we're doing a ratio. So divided by, or I could do a big line underneath there, but I'm not going to. Erase that sucker. Okay, divided by this column is 75. So the people who have the disease or who don't have the disease who were exposed over the people who don't have the disease who were not exposed over 380. And you can remember when we have this division situation right here, what we do is we flip that second thing right there. So we end up with an equation that 215 times 380, hello, 380, where'd my 3 go, divided by 785 times 75. That's the same thing that we talked about with if our hypothesis is correct over the hypothesis incorrect. But if you have a more mathematical mind, that's how we're getting that odds ratio equation, if that helps. That also kind of clarifies how that odds ratio is related to relative risk in the next slide. So then here, with relative risk, what we have is the incidence of disease among the exposed. So that's this part right here, incidence of the disease among the exposed. So these are all exposed. A plus B is our total of exposed. So incidence of a disease with the exposed. So A divided by A plus B. And then we compare that to the incidence of disease among the unexposed. So incidence of disease is among the unexposed is C, and then we divided by that by the total of the unexposed. So we've got that relative risk there. So we're still using those 2x2 tables, but it's slightly different. So odds of people with disease being exposed, and then relative risk is compared the incidence of the disease among the exposed and the unexposed. I know it's really hard, and I'll tell you that most people have a hard time thinking about odds ratios. It's just a really awkward math description, whereas relative risk actually makes more sense. So, because you can talk about, okay, so among people who smoke, and then compared to people who don't smoke, what's the relative risk of lung cancer? And it's a more intuitive thing to say, but the reason why we have to keep using those odds ratios is because we can't use relative risk for everything, even though if you can use it, we probably should, because it makes more sense. This is actually a debate that statisticians talk about a lot, because odds ratios are just hard to explain. So it's a little bit of something you have to memorize and kind of think about. One more thing that I'm going to say to you, and I'm not going to test you over it, but I just want you to think about it. If you have a very low incidence of a disease or prevalence, but if you have really low incidence of disease, then your outcome column, this one right here, is very high compared to the yes part, and relative risk is very close to odds ratio. So if you've got a disease that's just not very prevalent, so let's say, I don't know, I can't think of anything. Retinoblastoma, sure, it's a cancer in your retina. Very low prevalence and incidence. Its relative risk is going to be the exact same as the odds ratio, maybe not the exact same, but very close. And so we can use one to kind of approximate the other. And statisticians or epidemiologists often do that, and it drives statisticians crazy. So I don't know. I don't have anything more to say about that. So when we think about our study designs, here's a quick little thing to think about, which kind of measures we can get from each kind of study. So let's think about case control. Pause the video for a minute and describe to me what a case control study is. Okay, so what you just said was that you find, I don't know, like you find 50 people who are cases who have your disease and 50 people who are controls who don't have your disease, and then you ask them things about their lifestyle, either current lifestyle or looking back in time, as much as they can remember. So because you've got half cases and half controls, can you come up with prevalence? No. Can you come up with incidence? No. You can come up with an odds ratio, because you can talk about the odds of people with the disease who have an exposure over odds of people without the disease not having exposure. Yeah, but you can't do relative risk, because again, you can't do incidence. So this is a good thing to remember. Case control, you don't know what the general population is doing because you overloaded your cases versus your controls. And there's good reason for that, and it's definitely a useful study, but we can't come up with population incidence, population prevalence. So then let's think about a prospective cohort study. So a cohort study is what we call these, just plain cohort, but prospective means it goes into the future. We find them now, then we find them out to the future. So we find a group of people, and then we see if they get the disease. And along the way, we also figure out their exposures. So with our cohort study, can you do incidence? Yeah, because you're looking out to the future. Prevalence? Maybe. It depends on how you select your cohort. If it is a good selection where you picked people that are very representative of the population you care about, then prevalence you can approximate through your prospective cohort. But if you selected your cohort in a different way, it could be that you're not able to get prevalence. So that's why I've got a little tilde there. We can do odds ratio and relative risk because we have incidence there. So cool, prospective cohorts, awesome. We can get incidence, we can get odds ratio, we can get relative risk, but depending on how we selected our study, we may not be able to get prevalence, but we may be able to. Sweet. Those cohort studies, that's why they're really nice. Okay, cross-sectional, 1 point in time. So you tell me, pause it, see if you can come up with it. All right. Can't get incidence because we don't have a period of time. It's just right now. We can't get prevalence because we know out of our cross-sectional data who has it and who doesn't. Odds ratio is really hard to do, and relative risk probably, but maybe not. I'll tell you, so you're looking at this and you're going, what? Odds ratio and relative risk? How is that? These are just what we're going to say. We're going to say cross-sectional data, we can get prevalence, we can't get odds ratio and relative risk. And I'll tell you why. Because epidemiologists and statisticians actually disagree. About cross-sectional data, and they actually come up with a third measurement that I just don't want to add to your plate. So we're not going to. We're just going to say we can get prevalence from cross-sectional data, which is good. We can get prevalence among people who say they do something and prevalence among people who say that they don't, but we can't call that a relative risk. So could not. So with our relative risk, if we have selected a cross-sectional data where we can figure out the exposure and our cross-section is good, we could figure out relative risk. That makes sense to me, right? Because we can measure the exposure and we can measure the disease, and then we should be able to figure out the prevalence in each one of those populations, but technically it should be the incidence. Oh gosh, you guys, right? And like I said, epidemiologists and statisticians actually debate about this. Here's just 2 articles. So I don't think we're going to come up with the answer. So just for our purposes, we are going to say that cross-sectional data, we can do prevalence, and then we're going to leave it at that. So that's how we're going to, we've talked a lot about our contingency tables, those 2x2 tables, and like you guys were talking about in class, we can see if there's differences among our people who are exposed and unexposed, and whether they get the disease or not, and we can use our risk ratios, our relative risk and our odds ratios. We can use percentages, we can use proportions, we've got that done, but is it statistically significant? How do we tell the difference between a study that used a lot of people and a good cross-section of data versus studies that have very small sample sizes? And that's how we get to statistics. So that's going to be the next set of lecture slides, is how to use our statistics.